We looked at compounds earlier, so let's take a more detailed look at these compounds. Atoms combine in a whole number of ratios to form compounds, and the chemical formula of that compound tells us the ratio of elements. The subscripts in a chemical formula tells us the number of each element in one molecule, or the moles of each element in 1 mole of the compound. Just like 1 dozen is 12, 1 gross is 144, 1 barrel is 42 gallons, 1 mole is this big number, 6.02 times 10 to the 23rd. Let's take a look at a hydrogen-oxygen compound. Stop the video and answer this question. And the answer is H2O is not the same as H2O2 because in one H2O there's 2 H's and 1 O, but in one H2O2 there's 2 H's and 2 O's. So different subscripts, different compound. We know the chemical formula of water is H2O, so stop the video and answer these 2 questions. These questions involve conversion. What is the conversion factor? In one H2O molecule there's 2 atoms of H and 1 atom of O based on the subscripts in the chemical formula. Subscripts also represent moles, so in 1 mole of water there's 2 moles of H and 1 mole of O. So in 20 water molecules, use the 2H to 1H2O conversion factor, and that gives us 40 H's and 20 oxygens. 1 water molecule is so small we can't see it, so let's use moles. Stop the video and answer these 2 questions. And here are the answers. Here's our conversion factor. Make sure the units cancel out to give you the units you want. Practice makes perfect, so stop the video and try these 3. And the answers are, note that there are 2 moles of carbon in 1 mole of glycine. There's 5 moles of hydrogen in 1 mole of glycine. And there's 2 moles of oxygen for every 1 mole of glycine. More practice makes more perfect, so stop the video and try these 3. And the answers are, in your conversion, the original units cancel out, leaving you with the units you want. Ions are part of ionic compounds, so stop the video and answer this question. And the answer is, so remember that an element contains the same number of protons and electrons. When an element gains electrons, it forms a negatively charged ion or anion. When an element loses electrons, it forms a positive charged ion or cation. The periodic table helps us determine the charge on an ion. For example, sodium is a group 1 element, so sodium ion has a +1 charge. Chlorine is a group 7 element, so the chloride ion has a -1 charge. You may have heard the term isotope before. For example, the carbon-14 radioactive isotope is used to date fossils. Radioactive isotopes are used in medicine for therapy or diagnosis. So stop the video and fill in the blanks. And the answers are, the number of protons identifies the element, the number of neutrons identifies the isotope. The atomic number tells us the number of protons. Elements have a charge of 0, so the number of electrons equals the number of protons. And the number of neutrons equals the mass number minus the atomic number. The atomic weight tells us the average mass number of the isotopes of that element. So if we round the atomic weight to the nearest whole number, that tells us the mass number of the most abundant isotope. One important application of isotopes is to authenticate items like bottled water and fancy foods like olive oil. The International Union of Pure and Applied Chemistry is publishing a new table of standard atomic weight ranges rather than single values due to the natural variation in an element's isotope abundances. Let's go back to ions. Stop the video and identify the scientific principle that's involved in this picture. And the answer is Coulomb's law. A positive charge is attracted to a negative charge. We can use charge to help us write a chemical formula. The charge in a compound has to equal 0, so the positive charges has to equal the negative charges. Not only can elements gain or lose electrons, so can molecules. This table shows the charges of common monoatomic ions. Stop the video and figure out the charge on the hydroxide ion. And the answer is polyatomic ions are involved in ionic compounds. There are millions of compounds known. If you're working with calcium oxide, everyone around the world will know the compound you're working with and its properties. So, communication is important. Stop the video and review these naming rules for ionic compounds and molecular compounds. Let's practice. Stop the video and write the chemical formula of these compounds. And the answers are: have a table of common monatomic and polyatomic ions handy so you'll know the charge on monatomic and polyatomic ions. From the formula or name, give the name or formula. So stop the video and try these. Identify each compound as ionic or molecular first, and the answers are: the first compound is also known as lime. It's used in farming to raise the pH of soils. The common name for sodium phosphate is TSP. It's a common degreaser. Calcium carbonate is the mineral in limestone rocks. It's also used as an antacid. Sodium bicarbonate is used in baking soda. Carbon monoxide is a toxic byproduct of fossil fuel combustion reaction. N2O is also known as laughing gas. Acids are a very common substance, so stop the video and review these naming rules for acids. If you're curious how drugs are named, you can take a look at this document. So stop the video and apply those naming rules to name these compounds. Here are the answers. Let's first identify the compound type and whether the compound's an acid or a base. Remember, ionic compounds contain a metal, non-metal. Molecular compounds contain nonmetals only. You may not have enough experience to identify a substance as an acid or base, so find a table of acids and bases to refer to. And the names are: note the difference between pure HCl in the gas state and HCl in solution. If you're a Superman fan, here is the composition of kryptonite. In Chem 1A, the ionic compounds we'll look at have 2 ions only, not many like in kryptonite. Let's review. The chemical formula tells us the ratio of elements in a compound. The subscripts tells us the number or moles of each element. Speaking of moles, every October 23rd from 6:02 in the morning and 6:02 in the evening is Mole Day. This organism comprises 30% of all living things. Stop the video and calculate the moles of this bacteria that exist. And the answer is: that's a lot of moles.